Welcome back guys. Today we'll be continuing vector algebra. So today we'll be studying about dot product or scalar product of two vectors. So let me define what it is. So let A and B be two vectors, then the dot product of A vector and B vector is denoted by A dot B, this is our dot sign, and defined by A dot B vector. This is a representation that would be mod of A vector times mod of V vector cos of theta, where theta is the angle between them. So this was our dot product. So now there are some properties of dot product, important properties of dot product. So let us take a look at this. So we have A dot B is equals to B dot A. This is our commutative law. So dot product follows commutative law. So now number 2. So for two non-zero vectors, A and B vectors will be perpendicular only when the dot product, that is A dot B, will be 0. So this is important for checking the perpendicular condition, or we can also say that cos of theta is 90 degree. So this was number 2 property. Number 3, we have, these are the unit vectors I dot I. If you multiply two unit vectors in the same direction, whether for any case, that will be equals to 1. And similarly, if we multiply two unit vectors of different coordinate, this will be 0, or this will be also 0, or k dot I, this will also be 0. So the dot product of the different unit vectors will give 0, and for same unit vector it will give 1. Now number 4, we have A dot B plus C vector, that is equals to AB dot A dot C vector. So it is a distributive property. So it follows distributive law. Now number 5, suppose we have, let A vectors defined in terms of unit vector, that is A1 A2j plus A3k, and suppose we have B vector, that is B1i plus B2j plus B3k, and the dot product will give us A dot B, that will be represented as A1b, A2b, A3b3. We can see this works for the unit vector, because we will only multiply I by I. For the other, if you multiply I by j, that will give 0, I by k, that will also give 0, and similarly for all this, only the same component unit vector will get multiplied. So this was 5th property. And there is some small note. We can then say that if we write A dot A vector, we can also write it as A vector square. So these are equivalent. So these were the properties and definition of dot product. So if you had any problems, comment below, and if you did like my video, hit the thumbs up button and subscribe to my channel for more videos. Thank you.